Assalamualaikum student. Today we discuss the topic that is the application of Bernoulli equation. Application of Bernoulli equation first used in the filter pump. A filter pump work on the Bernoulli principle, which state that an increase the speed of a fluid result in decrease the pressure water flows through a tube. Here the water flow through a tube and speed increase. The speed of water increase, then it decrease the pressure around the jet drop. This decrease in pressure, when the water flow from this nozzle or jet, its pressure is decreased. When pressure is decreased, this decrease in pressure pull air from a side connected tube, that is the vessel. This decrease in pressure pull air from a side connected vessel. This create a partial vacuum. Here is create a partial vacuum when they pull the air from the vessel. This create a partial vacuum in the vessel, which help to suck more air and water for filtration. Now we discuss the atomizer. An atomizer work using Bernoulli principle. An atomizer work on the Bernoulli principle. How it is work? Here is force through a narrow tube. Here is force into a narrow tube, making it faster and decrease the pressure. This decrease in pressure creates a suction effect. This suction effect pulls liquid from a connected tube. Here the suction effect is produced. This suction effect pull the liquid from this tube. As the liquid meet with the fast moving air, this liquid meet with the fast moving air, it change into tiny drops. This liquid then spray out as a fine mist. This is how spray bottles, perfumes, spray, etc. works. Now we discuss the another application of Bernoulli equation, that is the engine carburetor. How the engine carburetor work? Air enter the carburetor through a narrow section of the tube, which increase the pressure and decrease the speed and decrease the pressure. So here we write air enter the carburetor and passes through a narrow section of the tube, so it speed increase, which causes a decrease in pressure. Decrease in pressure creates a suction effect that drawn fuel from the fuel jet. Here the pressure decrease which suck the fuel from the fuel jet. This air and fuel mix together, forming a combustible mixture which is sent into the engine for combustion. Today we discuss the application of Bernoulli principle, that is the Torricelli theorem, that is also called the speed of efflux. This law states the relationship between this law describe the relation between velocity and depth of the fluid. Here we use a container that is constant of a liquid made at a different height. The depth of the liquid above each hole determines the exit velocity from that hole. Liquid at a greater depth in a container is under high pressure. In this case, the liquid is under the high pressure. In this case, the liquid is at the low pressure. When the liquid is at the low pressure, its speed of water decrease, and when liquid at the high pressure, its speed increase. So here we write that liquid at a greater depth, here liquid at a greater depth in the container is under high pressure. When the liquid is under high pressure, this high pressure force the liquid through a small hole in the container at a greater speed v. Now we write the equation of the Torricelli theorem, or we use the Bernoulli equation. We use the Bernoulli's equation, that is the P1 plus half rho V1 plus square plus rho GH is equal to P2 plus half rho V2 plus square plus rho GH2. So here P1 is equal to, at the top of the container, the pressure at the bottom and at the lower and top is equal. The speed at the top is equal to 0 and the bottom is equal to V. The height of this hole from the bottom is h2 and from the top is height is h1, so its height is equal to h. If we minus the h2 from the h1, so here we write P plus P1 is equal to 0, so this bottom is equal to 0, plus rho GH1 is equal to P2, P plus half rho V2 is equal to V, so V square plus rho GH2. This term is cancelled out, so here we write rho GH1 is equal to half rho V2 square plus rho GH2. This quantity come here and become minus. Here we take the common rho, and GH1 minus H2 is equal to half rho V square. So this is cancelled out. So here we write rho GH1 minus H2 is equal to V square, and the final term we write V is equal to under root rho GH1 minus H2. That is the speed of flux. It is calculated by the Bernoulli equation. Today we discuss the application of Bernoulli principle is the Venturi meter. What is a Venturi meter? The Venturi meter is used to measure the rate of flow of a fluid flowing through the pipe. Now what is the principle of Venturi meter? The working of Venturi meter is based on the principle of Bernoulli equation. Venturi may consist of three parts. First one is converging part. Second one is stored, and third one is diverging part. This is the Venturi meter. Here is the fluid flow in a pipe. This is pipe, and this is the converging part. This area is stored, and this area is diverging part. Now we discuss is working of Venturi meter. As the water enter at the inlet section, that is the converging part. It converge the fluid and reach to the throat area. As the water enter in the throat, its velocity increase due to the pressure drops. It create pressure difference. Difference in pressure measures with the help of manometer. Manometer help in determining the rate of fluid flow. Now we write the equation of manometer according to the Bernoulli equation. That is the P1 plus half rho V1 square plus rho G H1 is equal to P2 plus half rho V2 square plus rho G H2. So here the height of pipe is same. So H1 is equal to H2 is equal to H put it here. So we write P1 plus half rho V1 square plus rho G H is equal to P2 plus half rho V2 square plus rho G H. This will be cancel out. So P1 plus half rho V1 square is equal to half rho V2 square plus P2. Now by equation of continuity, equation of continuity, that is the A1 V1 is equal to A2 V2. So V2 is equal to A1 V1 divided by A2. Put in this equation. So here we write P1 plus half rho V1 square is equal to P2 plus half rho V2 square A1 V1 divided by A2 whole square. Now we can write that P1 minus P2 is equal to half rho A1 square V1 square divided by A2 square minus half rho V1 square. Now we can take common half rho V1 square. So inside we get A1 square A2 square minus 1. So this equation can be write as A1 square minus A2 square divided by A2 square. Here we can calculate V1 square to P1 minus P2 rho A1 square minus A2 square divided by A2 square. This come in upper side, so we can write A2 square to P1 minus P2 divided by rho A1 square minus A2 square. We know that P1 minus P2 is equal to rho G H. So put it here. V1 square is equal to 2 square to rho G H divided by rho A1 square minus A2 square. This will cancel. So finally we get V1 is equal to A2 to G H over A1 minus A2. This is the velocity of the fluid that flow in the Venturi meter. Assalamualaikum student. Today our topic is the airfoil, that is the application of the Bernoulli principle. How we discuss the how aeroplane fly. Here we take the example of the aeroplane, how aeroplane lift upward. Aeroplane is designed such like that the air flow higher in the upper portion and low in the lower portion. When the air moves slow in the lower portion, it creates high pressure. When the air moves fast, it creates low pressure. So the pushing force is produced. This pushing force is moved from the high pressure to low pressure. This pushing force is called the lift, so that the plane lift upward. So here we write the basic principle behind an aerofoil is Bernoulli's theorem. The curve upper surface of an aerofoil causes air to move faster over it, creating an area of lower pressure. The flat lower surface maintain the higher pressure. This pressure difference between the upper and lower surface make the air below it push the upward. This pushing force is called lift. Allowing this pushing force or lift, allowing an aircraft to place against the force of gravity. Blood flow. Here we discuss the classification of blood flow. Blood flow in the human arteries depend on the radius of its arteries. Here is the blood flow is normal when the artery is normal. When fatty material builds up, this will cause the blood material in the arteries that reduce the blood flow rate. When fatty material builds up in the arteries, then the heart would have to increase the pressure to maintain the blood flow rate. The pressure is lower where the blood flowing faster. This pressure difference here is the increase the pressure is the pressure, lower this pressure difference can dislodge the plug. This plug block artery which can cause heart attack.